in the last session, I said I wasn't going to get involved with the details of the this last session I'm going to do. That is the the find the most relevant features the correlation. So I said so I found a way to make it a little bit very explicit and just so quick. So we'll just go through it. So let's create our find the most relevant features that are really important for that we a discuss. So so what I'm going to do, how we're going to find this relevant feature is that like each of these variables now they have been formatted already and they are all numerical values now. I would say, and then we want to find the correlation with the target value because for you to find the most relevant features, you just one technique to find it. It's not like all rounded stuff. You need to find the the variables the variables that are direct somehow direct that somehow are related to the target values a little bit correlated a little bit. You get not they are as if they are disjointed, just different. You have no relation with it. So if your if most of the feature what do you call it, the features don't have any form of correlation with the target value, we're going to find it difficult to have a very good model. Um, I will call that's what it's called underfitting. So there should be. I'm not saying that the correlation should be so high. It should be just it should be 0.2, 0.3. That is in percentage. I would say. Um, it should just be at that level, but it should not be like minus. Most of them are minus, 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 minus. Your model will be so hard to train. It will take hours, and you will actually you know like achieve a very global maximum. So that's something you need to know. So that is the way we're going to find our relevant feature. There are other ways to find relevant feature. Other ways plot you could plot just really the features against each other and then find the relevant features based on okay if this one is matching this one, if this one is still passing the same information. For example, let's say this worship and neighborhood, they may be saying the same thing. They are when you plot their progression the graph, you see that they are following the same curve and everything. So you're just overfitting the machine learning model, you're just giving it the same data 2 times. So why can't you just take one? So that's one reason. One that way you could choose features by selecting one feature, selecting one feature that selecting one feature of two related stuffs. It just we say, but the way we're going to do here is we're going to do by correlation. That is, your features should have a little bit of correlation with the target value. So our target value is sales price. So as there's a method on pandas. Um, no, it's not. It does not say with the vibe, so I can just print it out when we call it. So let's go train dot correlation. Then we have to now pass in the sale price. So is we are trying to correlate all the features with all the sale price, like how they vary, So let us spread this. Let me check whether I could times this by 100. So we can farm it from okay, yeah, it's okay now. So as you can see, the correlation between a target value. This ID. I was meant to remove it since this ID is just uh, is random. Like it gives just it's an ID identifier, just random stuff. So it doesn't pass any information. I forgot to remove it. So that's why you see that it's minus 2 points. So you can see this what is auto yes auto is actually giving an information about it. So this is ideal for me. When your um, features are 26%, 30% correlation with the sales, 40% correlation with the that's why the target, with the dependent variable, I would say, because in the machine learning, you have a feature and a target. You're using those features to predict target target. Now we're trying to predict the sale price based on the features that we have. So there should be a form of at least a little bit of correlation, but it should not be too much. If it's so much, then we'll be an overfitting model, and the model overfit. I've explained overfitting to us recently. You're building, so the model will not be very model will not be very smart. Cannot tweak, cannot run very variable inference in unseen data or stuff you don't have available. So we have to make it available. So as you can see, this what area is a really nice feature to use. But this overall quality, you can see this overall quality is overfitting. Like I said, if it's 40%, 30% is ideal, but 80%, 70, 60, you're not overfitting the model, because now if the model should see this overall quantity, it knows that the price is affecting the price, it's directly affecting the price already. So the model doesn't have to work very hard, have to stress itself to understand on that underlying stuff about it, because this overall quality might not necessarily be, but this overall quality is actually the right thing to, like, yeah, if the quality is related to the price and all of that, but it might hinder it for me to learning other stuffs. You get learning other stuffs. So that is, for example, I give an instance, we in exam hall, and you know that like you have to, that when you go to when you go for exams, you have somewhere that you copy from. You don't have to read. You just read small small sections of your course, and you not get more information in that course, because of you already have someone that will read for you. So it is hindering it. So this is not a feature that will take. This year build, yeah, is ideal. 52% is okay. 52%, all these ones are okay. This one is not okay so much, and 60% and 70%. This one is totally correlating with it, and it's going to overfit. 64, not bad. That, like, you can see now this sale price is actually what we're correlating with. I can see that it's 100%. That is overfitting. Like, example, you're giving it the answer and you're telling it to sleep with it, so it doesn't need to learn anything, because machine learning models learn with something called loss function. Like, it trains itself, but loss function is more using deep learning. It trains, like, for example, it predicts, and once it fails, it go back and retrace. So it's based on the feedback it's getting from the result that it predicted, that it's try to get better. So if you're not giving it if you're telling that you're passing it, that it's getting it, it doesn't need to train itself again. It just needs to, like, overfit, like, thinking that it's at a good place. Just example, thought you have read for all the courses that you have exam, and also all the topics that you have in your course, and then you don't know that you have just read only one topic, and just you get surprised on exam day. So that kind of stuff. So yeah, so this are ideal. This one's ideal, 3%. But this one is really bad. It's really bad, because it's minus 6%. It doesn't have any. So we could just remove it. We should just remove this. It's bad with correlating. So we just remove this also. Like, yeah. Once it's minus, it's going to be under fitting so much. Actually, it should be like 0.00 something. Yes, that was manageable, but it's going to fit so much if it's minus something. So most of all these features are not, like, relevant and all that. Yeah. So that's how you choose the relevant features. This is just one method. I've told you about the other one, where that you just find, use, you plot, or do the correlation between the features without without um doing the target. For example, let me show you what I mean by that. That's what I explained earlier on. We can also do it here, but we don't need to, like, use the sales price. We just correlate it based on itself, so we can find if a particular feature is passing the same information, like it's still the same thing with someone else, with someone other feature. So we just remove that overfitting stuff. So let us check it. So if they are the same percentage, then we know that So that's it. So that is how it is. So you can see the ID is 100%. And the what area, then we can see that it's the ID, like it is printed a 2D 2D array for us, and so it's explicitly arranged. We can see now this is correct to itself 100%, 100. So it is not rep- like kind of, it is not taking another like passing the same information, it's passing a different information, but it's not useful for us now. So we can see 100, that is all these ones, they correlate to themselves, they're passing the same information to themselves. So we just find one that has a very high percentage. Then we'll now see what I'm talking about. 59, and this one has 59% with year built. We can see that they are almost correlating, but it's not so strong for us. We just find whether we see a 79%. 79%. This is sell price is correlating with overall quality. We can see that same thing. So it's actually passing this information for us. So let's find another one again. Something very very high. We don't see anyone that's very high that is passing the same information. Okay, we have separate. I think that should be quality. This is 2%. Uh, so, but you actually, I think you get the point now. Like, w- using this one, just correlate it with the target variable or the dependent variable, and then check how they correlate, and it shouldn't be so much. If it's minus, it means it's going to underfit. If it's so high, it's going to overfit. So it has to be like normal 50%, 30%, and all of that. And this just try to spawn out the whole repetition of information, passing the same information to it. Like, okay, now, for example, like we saw this year mode, it is somehow it has a 59% correlation with year built. Somehow they are somehow passing the same information. So are you going to spend that energy to give your machine learning model the same information two times, or just use that and give it a new information so you can learn better? But this is actually ideal, but I mean, I didn't find a very high value one. Yeah, 59 is not like still bad. If it's close to 70, 80, then like you're dealing with something else. So thank you for this session. Yeah, and it's over. We finished all this for this session, and I hope you learned something through our whole process of data processing. And it's just the first stage into the machine learning world. But it's just good we know this, so when we start with the models, now we can like do this, and like talk so much about it. So see you in the next module. Thank you very much.